Shall we play a game? Hello everybody, this is Nino, and in today's video we shall teach a machine intelligence to play with us tic-tac-toe. It will happen by means of what I am calling challenge-reply pairs. If you do not remember them, let me repeat once again their main idea. You challenge the system with some sort of pattern. The system compares this pattern to a database of challenge-reply pairs. It finds a most similar pattern in the challenge section and gives you as a reply the corresponding reply section. And when you thereupon answer to the system's reply, then, because you are the intelligent entity and what you do is presumably intelligent, the system is going to learn from you by saying that what you replied is a proper response to that which the system has last shown you. In this case, we shall look at the tic-tac-toe board, and my move and the system's counter move are going to be the elements of my challenge-reply pairs. The idea of tic-tac-toe, a game from your childhood, I believe, is so simple that it needs no further explanation. But for your convenience, kindly remember the field in this setup will be divided as follows. The letter A will be the topmost row of the game field. The letter B will signify the second row, and the letter C the final row. And the columns will be signified by the numbers 1, 2, and 3. This is already giving you a little feeling of how the game will proceed, and that in the end O will win. So that's going to be the game we play, and now let's actually play it. First, however, I would like you to see the system's knowledge base. It could contain as many knowledge reply pairs as you like. I have limited it currently just to 20. But you see, in each case it just knows an empty board. Basically, this is always a challenge, and that is always a reply to it. It will learn to which board configuration what other board configuration is a proper reply. Notice one funny thing in this setup. It has no idea of the movement of figures or the patterns of solving tic-tac-toe at all. It simply says it is going to learn what board situation is going to be responded to with what other situation, and according to what rules this other situation comes into being, it has no idea. Its learning is purely heuristic from the interaction with its user. Now, let's actually play it. Alright, let's call up the game. And off we go. I shall play with O. Now, because in this game X is starting, it is asking me to say the first board position for the machine, and I'm going to select the center position. Place an X on B2, which is the second column and the second row. So the machine reply is, it just took what I told it. It is an X on the position B2, and it wants me to say where I will input my O, basically. I'm going to place it in the topmost right corner, which is on position A3. The machine reply to that is just a guess, which is X at A1. In this case, I really have not let it think at all about its replies. It's just what it does if it has no better idea. So now the board situation is an O on A3 and an X on A1 and an X on B2. My next turn is going to be, I'm going to creep down the right column, so I'm going to say place an O on B3. The next machine reply is X on A1, and now comes X on A2. You realize it is really just following line by line, as it has no special algorithm to play by rules. And I'm now going to win the game by placing an O on C3, thereby finishing the last element of the right column. It recognizes that the column has been fulfilled, the winner is O, and the game is over. Now we shall have another look again at the knowledge base, and my editor is already inviting me to reload it. Here you see 20 pairs of empty input and output, and this is going to change as soon as I press reload, as it will show you how the system has learned to play from our past interaction. Alright, don't pay attention to the fact that the knowledge base is no longer so nicely formatted. That's not material to the consideration. This is basically Lisp, so it just matters what is in the list, not what the list looks like. But notice, here towards the top, you can clearly see that the system is no longer having no idea at all what to put into the fields. It has actually accumulated a series of challenge-reply pairs from the interaction with me. For instance, here you are seeing such a challenge-reply pair. In each case, it has learned what board position can be followed by what other board position, without actually ever having learned the rules of the game tic-tac-toe. It only has learned what situation follows what other situation. In other words, it operates merely on the basis of patterns, not on the basis of targets, goals, aims, cause and effect, or any other such system. It just checks the correlations and tells what situation should follow. The proof lies in the pudding, and I shall now play one further game against the machine. This time I will be playing with X and I will lose, and the system will win against me according to what it has learned from the last game with me. Starting the game again. This time I am playing with X. Now it tells me it cannot reply anything to that because I am the one to start. I'm placing my X in the center, the way last time the machine did it. And lo and behold, the machine is actually replying with an O on A3. This is what I did previous time, and it has learned that this is a proper answer to an X having been placed on B2. Okay, now I'm going to place an X on A1, the way the machine did last time. And now the machine will give me my previous reply. It is going to place an O on B3. Okay, I'm now going to place an X on A2. And the machine places an O on C3 and wins the game. It now has fulfilled the entire third column. And once again, it has updated its knowledge base, which you can easily see here by the reload request. And generally speaking, by looking at the knowledge base, you can see here a lot more positions which have signs in them, which show that it now has an idea of at least some instances how to play the game. Well, that wraps it up, and I hope now the usage of challenge-reply pairs is a little bit clearer. I believe this shows that challenge-reply pairs can be used in a very general manner. And even if you have the illusion that a game follows rules, in reality, the things which you are observing can be easily expressed as patterns upon patterns. And if you are making out rules, it is just a manner of filtering patterns more clearly. However, everything can be reduced to patterns and can be expressed by challenge-reply pairs. So, I hope you will have much fun with this. I wish you great success in your artificial intelligence experiments, and I would be very grateful and happy if you could check my further videos. Have a very pleasant day. Goodbye.